Hello and welcome to episode 5 of my JavaBot tutorial. Today I will teach you how to make a dodge. Dodges are great to get a lot of momentum without using any boost, but they can be a bit tricky to implement since they are a sequence of actions. And I sadly see a lot of people implementing it wrong on their first try, and I think it's because they don't understand how the game and your bot communicate. So the very first thing I'm going to do in this video is making a generic explanation about how the framework works and how you should make your dodge. And I'll make it generic enough that you can understand it even if you're not making a Java bot. So RLBot is basically a bridge between Rocket League and your bot. It takes game tick packets from the game and sends it to your bot, and your bot then responds with a controller state describing what it's doing. And it's important that you understand that this controller state is just one combination of buttons describing one moment. And this exchange of information happens 16 times a second by default. So 16 times a second you're saying, I'm doing this right now. The mistake that I see people make is that they write something like this. They create a controller and then they set jump to true, then set jump to false, then set pitch to -1 to start the front flip, and then jump again to start the dodge. And the idea is correct because those are the steps in a dodge. But here we are talking about just a single controller. And these 4 statements in a row just evaluates to one controller, which has pitch -1 and jump true. So what you're telling the game is that you are pitching forward and jumping, but you're only doing it for one frame. So it won't be a very high jump, and it will definitely not be a dodge. And this is what I mean when I say that dodges are a sequence of actions. It's a sequence of controller states. And when we have a sequence, we have to think about the time. So when you want to make a dodge, you should store the time of the start of the dodge. And then for the next few seconds, you should send controller states back that has jumped true. This will be the first jump, and I recommend you do it for something short like 0.1 second, but this is just an example. Of course, the more controller states you send back where jump is true, the higher you will jump. Then in the second phase, you should start pitching towards your target, so here I'm just pitching forward for a front flip. And again, this is just a very short amount of time. In the third phase, you have the second jump, so this is where the dodge starts. And here you should also still keep pitching forward. Then lastly, give some time for the dodge to finish rotating, and maybe even for a stop when you hit the ground again. So to summarize, a dodge is a sequence of different controller states, and you have to store the start time so you can compare the start time to the current time and then calculate in which phase you are. You will end up with some code that looks a bit like this. Now this is just pseudocode, and hopefully you can translate to whatever language you're writing in. But I recommend you do it in a class. So in the constructor you can give it all the game data, and then you can set the start time to the current amount of elapsed seconds. You're also going to need some boolean, here I just call it done, which will flag whether the dodge is done or not. Then as long as this done is false, then you should keep calling execute. And the execute function will create a new controller and then calculate how far you're into this dodge, and based on this time we can set the controller's buttons to the correct state. So you can see the 4 phases from before, I've colored them here. The first jump, the rotation, the second jump, and the wait. After you're done waiting, you can set the done flag to true to indicate that the dodge is now over. So somewhere else in your code you will have a dodge variable, and if it's not null, then you're currently doing a dodge, and you should execute that dodge. If you then see the dodge is done, you can set the dodge variable to null again, and if you're not dodging at all, well, then you can consider if you should dodge right now. And you start a dodge by simply setting the dodge variable to a new dodge. Now this is of course a very simple and a bit hard-coded version of a dodge, but this will give you the idea of how to get started, and from here you can make it a bit more flexible or a bit more advanced, and you can adjust the timings to whatever you need. But I hope you see now how you have to keep track of the time to make a proper dodge. Now, moving on with the video. Before we start implementing the dodge, there's a few things I have to let you know about. As you can see, I have changed the appearance of Goblin. And that's because I was originally going to make episode 5 about bot appearances and how to customize your bot. But just as I had recorded that, a new update came out to the Albot GUI, and it just made customizing your bot so much easier. So instead, I ended up making a video about that, and if you haven't watched it, go watch it so you can give your bot a cool appearance as well. Another thing I did was changing the opponent, so now our opponent is actually named All-Star, and it is a Psyonix All-Star bot. I'll just show you quickly how to do this right now. To change which cards are in the game, we go to this albot.config and we find the participant configs. And here we put in the path to the bots that are in the game, but whether they are Psyonix bots or AL bots depends on this variable down here. So we already set this one to Psyonix in a previous episode, but now we also want to change the path to point to a config file for an All-Star bot. And as you can see, the All-Star bot is in its folder called Psyonix. And the All-Star config file simply has a looks config, it has no Python file path, and then it has a name of All-Star. We don't have to set the Python file because it's a Psyonix bot. And the looks config here is just the default appearance for bots. And that way we now have an All-Star opponent. Though keep in mind that sometimes it can be very useful to play against yourself, because you can see more scenarios happening, and you also make sure that your bot works on both blue team and orange team at the same time. But now you know how to switch between the two. Now let's start making the dodge. First we're going to need an interface for all of our maneuvers, because dodges are just one kind of maneuver. We could also think of other maneuvers which we want to implement in the future, like aerials or half flips or wave dashes. So we'll make a package for that and create an interface called maneuver. The maneuver interface will have two functions. We're going to have an execute function so we can perform it, and we will have a done function that will return true when the maneuver is done. So they're a bit similar to states, but we expect maneuvers to tell us when they're done. Now let's make the dodge maneuver. The dodge maneuver class of course implements the maneuver interface. We're going to have a boolean to keep track of if we're done. And then, as I said in the start, we're going to save when the dodge start. That'll be a boolean called start time. We're going to set the start time in the constructor. We're just going to receive the whole packet so we can pick the in-game time that is dated.time. And again, it's important that we use the in-game time when we want to do something that is time dependent. That way we are not affected if the user pauses the game or if the time is slowed down in any way. The in-game time will always match what we expect. The done function will of course just return a done boolean. Now we're going to implement the execute part of the dodge, and that's going to be the hard part. First we need to find the timings for a dodge, and I've gone ahead and find some that I like. You can see them right here. We're going to have 5 phases in this dodge. First we're going to jump for 0.09 seconds. Then we have a phase that I actually ended up not using, but that is some time between the first jump and the beginning of the rotation, or the aiming as I call it. The next phase is the aim phase, and this is where we are starting to rotate towards our target, and we'll do this for 0.08 seconds. Then the second jump happens, and we'll press the button for 0.28 seconds this time. So a bit longer, but it actually doesn't matter for a dodge. And lastly, we're going to wait a bit for the rotation to finish, and that is the post second jump pause. That one will be 0.14 seconds. So if you sum these up, you'll get the earliest we can end our dodge. But in fact, we also want to make sure that we land on the ground again. So there's going to be like a recovery phase, but we don't have a recovery state or maneuver yet. So for now we'll just wait until we hit the ground, and you'll see that in a moment. So we're actually going to need to calculate when all of these phases starts and ends. And that's the first thing we'll do in the execute function. So that will look like this. The first jump ends after the first jump duration. The aiming begin after the first jump has ended, plus the pause that we have between the first jump and the aim, and so on and so forth. It's the same pattern all the way down. Then we're going to calculate the current time, and that is the data time minus the start time. So this will tell us how far into the dodge we are. And by comparing this current time to these times above here, we know which phase we're in. Let's just first create the controller that we are going to return. So we now have a controller here, and I'm going to set the throttle to 1. It rarely matters, but in some weird cases we can end upside down and whatnot. And this throttle will make sure that we end up on our wheels at least at some point. Now let's check which phase we're in. So if our current time is less than the first jump end time, then we will jump. Now in this second phase we'll just hang in the air and actually just wait. The third phase and the fourth phase are actually kind of similar. In both we want to pitch our car towards our target. But of course they are not completely identical. In the fourth phase we also want to dodge. So we set jump to true if the current time is above the second jump begin. In the fifth phase we are again just going to wait and let the car rotate. And past the fifth phase we are done, and we set our done variable to true. Lastly, of course, we have to remember to return the controls. And that should be it for a simple forward dodge. Now we just have to use it somewhere. We're going to add it to the kickoff state, and we're also going to add it to the MoveToPointState. In the kickoff we will of course dodge when we get close to the ball, and in the MoveToPointState we will dodge if we have far to the target destination. So here in the kickoff state we're going to have an instance of the dodge, and then we add this small if statement. So if we are close to the target, which is just the center of the field, in that case, if our dodge is still null, we will begin a new dodge, but if we already have a dodge, then we will start executing that. And then we just have to add that when our kickoff ends, we will also delete this dodge. Now we are almost ready to test it out. There's just one problem, and that is in the Goblin class here, right here. The problem is that we are creating a new kickoff state every tick. We don't want to do that. We need to only create a single kickoff state, so we can remember that we have also started a dodge when we get that far. We should just initiate a new kickoff on each kickoff. So we're going to add this little change. We just check whether the state is currently a kickoff state, and if it's not, then we'll set the state to a kickoff state. And it indeed works as intended. Now you might be thinking, what is going on? Why is this just a kickoff over and over? And that is because I'm right now using Albert Training here to test this. Albert Training is a tool made by DomNomNom, and it's really great for setting up some test scenarios where you want to see how exactly your bot reacts in that situation. To use it, you'll need a script like this one. Here I've just made a folder called training and put a kickoff training in here. And I won't be explaining this too much. But if you want to look into this tool, you can find some videos on it. Again, it's called Albert Training, and once you have a file like this, you simply just go into your console and run this command, and then you'll have kickoffs over and over and over. You will be able to find this file on the GitHub repository if you want to try it out yourself. And remember to install Albert Training. You do that by writing pip install Alba training. But it is likely you already have it because you have Alba. And one more thing you'll need to do to use the kickoff training here is you need to go into the data packet and change the definition of isKickoff. Now you should simply just check if the ball is in the middle of the field, and we don't care about if it's actually a kickoff countdown or anything. But that was more of a side note. Let's get back on track. We now have a forward dodge on the kickoff. Now let's add the dodge to the MoveToPointState as well. The idea behind the MoveToPointState is that we're just trying to reach a generic point in some way, and we could add a dodge to this. So the idea will be if we are far away but we're heading in the right direction, then let's dodge. First, however, we are going to make a small change. Throughout the code there's currently some variables keeping track of whether we want to boost or throttle, or how much we want to steer, and then the controller is built as the last step. We're just going to pull out the controller here and then just set the variables as we figured them out, a bit like we just did in the dodge. So we start by creating a controller and we remove these lines, and here we instead just say controls with throttle, and down here it's controls with this expression as throttle, and this boost one is of course replaced with controls with boost. This become controls with steer, and lastly we just return this controller. And once again we will have an instance of the dodge maneuver. And if we're currently doing a dodge, that is if the dodge is not equal to null, then we should continue dodging until it's done. So if the dodge is not null, then we check if it's done. If it's done, then we null it. Otherwise we will continue executing it until it's done. Down here, after we have found the target in local coordinates, we will now consider if we should dodge or not. Now there's a lot of conditions for doing this dodge, and one of them is the distance, so let's just calculate that. And that is as simple as the magnitude of the car to target. We also want to check if we are heading the correct direction, because we only want to dodge if we are actually going the correct way. And to calculate that, we will use the dot product between the car's forward and the car to target vector. And we already got those right here. So let's pull this out and calculate it only once. Like this. So now we have a forward dot target. And down here we are just comparing the forward dot target to 0.8. Now let's define the conditions for when we want to start a dodge. And there's quite a few of them. So first of all, we want to be on the ground, so we need has wheel contact. We also don't want to dodge while we're on the wall, so we need car is upright. Then we need a good distance. Here I choose 2200. Then we need to face our target, and we're going to be a bit more precise than with the boost, so here I choose 0.9. If you have ever dodged while standing still, you will also know that it's not quite effective. You need to have some speed before you start dodging. So that's why we have this condition. The magnitude of the velocity should be more than 650. And that's it for now, so let's create the dodge here. But since this is just general movement, we also want to be able to control whether we dodge or not. So we are going to add a boolean more, which is just whether or not we are allowed to dodge. So we add this allowed dodge boolean up here. By default it is true. And we add it to the list of conditions. I just put it first here. Now let's try this out to see how it works. And lo and behold, we are now dodging. So what we just saw here is that the bot also dodges on the kickoff. and we might disallow that. So let's just go fix that. And that is as simple as going into the kickoff state and say allow dodge false. We want to manually control this, and that's what we do down here. Now I've just entered the game here to show you one more problem with the bot. And that is, if the ball is far enough away, he will of course dodge, but then as soon as he lands again, he will try making another dodge. And that can cause a bit of problems with his steering. So ideally we want a very small delay between each dodge when we're just moving around. Hopefully you can see what I mean in one of these clips. So to have this small pause between dodges, we need to keep track of when did the last one end, and then of course we need to define how long that pause is. So I just added two doubles here, one to keep track of the end time and the other one to define the delay. We will update the last dodge end time right here after we set the dodge to null. And then we add one last condition down here that checks if this time has passed before we begin the next dodge. We also have to go into our dodge maneuver and make sure that it's not done before we are actually on the ground again. So instead of just saying true here, we're going to say done if our car has wheel contact. As you see here, there's now a slight delay between the dodges. So now we actually have a functioning dodge, but it can only dodge forward. What if we wanted to dodge sideways or diagonally or just towards some target? Well, we can easily make that change. Let's implement it so that you can set a target, and if the target is there, then we will dodge toward it. If it's not there, that is if it's just null, we'll just dodge forward. So we'll now add a target to our dodge maneuver, and we will then make a constructor that also takes in a target. And to change which direction we're dodging, we have to replace this pitch down here. If our target is null, we are still just going to pitch forward. When our target is not null, we will have to translate our target into local coordinates again. And then based on the local coordinates, we will set our pitch and yaw so that they match whatever direction we're trying to flip. So finding the target in local coordinates looks like this. We've seen this before. And the direction we want to dodge is then the target in local coordinates, but it's now flattened, so the Z component is 0, and then we normalize it. Our pitch will then be the direction's X component negative, and the yaw will be the Y component of the direction times the sign of the orientation's up director Z. And that is because when you're upside down, then right becomes left and left becomes right. It's not something you notice as a player, but that's how it is relative to the car. But this sign function is not defined yet, so let's just do that. In the utility packet, I'm going to add a class called allMath, and here we're going to define various math functions that we're going to use and again and again. And this is our sign function, so it's just a value, and if that value is positive, then the return value is 1, otherwise it's negative 1. And then I just add allMath back here and it should be fixed. This to local transformation is also something we're going to do multiple times, so we will actually just move that to the allMath class as well. Like this, so we can translate a target position to the local position observed from this bot with this orientation. And now in the dodge maneuver we can replace all of the calculations with just a call to the toLocal function, and then we got our local target. We can go do the same in the MoveToPointState. Here we have the same calculations right here. In here we have a few cases that uses the car to target vector, so for that reason we can't delete that line, but we can still do this. So now our dodge should actually be able to dodge towards any target. So in the move to point state, let's dodge towards the target we're also moving towards. And the target might change, so we will update the target of the dodge right here before we execute the dodge. And when we create the dodge, we're also going to add the target. In the kickoff state, we can also make sure that we dodge towards the ball when we dodge. And again, we just update right before we execute the dodge, so we add this line right here. And hopefully that is it. We probably won't see that big of a change, but now it's there and we can use it later. Remember, if you want to have a bit different dodge, that is easy, you just change the timings a bit. I can also recommend watching one of Tahad's videos about his speed bot called Volleybot, where he implements kind of an action system instead. It's a bit more involved and uses a bit more object-oriented pattern. And it's way less hard-coded, which makes more things possible, but it then also requires more code, which is why I chose to implement this simple and bit more hard-coded version in this video. I'll put a link down in the description to the Volleybot, and I'll also put a link to Albert training if you want to look into that. And yeah, have fun till next time. See ya.